Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at rectangles. So remember, a rectangle is any quadrilateral four-sided shape with four equal angles. And of course, in a quadrilateral, since angles add to 360, four equal angles means that all four are right angles. So you probably already know the area of any rectangle is just the length times the width. Probably also aware that a square is a special type of rectangle with all four sides equal. So if we here have a square with side lengths 1 centimeter and 1 centimeter, its area is just 1 times 1, which is 1 centimeter squared. I know, shocking, right? But of course, 1 centimeter is equal to 10 millimeters. So this side is 10 millimeters, and the top side here is 10 millimeters. So the area in millimeters squared is 10 times 10, which is 100. So it turns out 1 centimeter squared is equal to 100 millimeters squared. You're probably already familiar with this conversion chart here, but when you're converting square units, you need to square everything. Even though there are 10 millimeters in a centimeter, there are 10 squared or 100 square millimeters in a square centimeter. So let's put a squared on everything in this chart. So by similar logic, there are 100 centimeters in a meter, so there are 100 squared or 10,000 square centimeters in a square meter. When you're converting square units, you need to square these numbers called the conversion factor. And so here the rule is, if you are going from a smaller unit to a larger unit, you divide because there are fewer of the larger unit. And if you're going from larger to smaller unit, you times because there are more of the smaller unit. So this is basically what area is. It's how many of these squares can fit inside a 2D shape. So if a shape has an area, for example, 50 centimeters squared, it means 50 of these 1 centimeter squared squares will fit inside the shape. So you probably already know how to find the area of a rectangle. Let's look at some harder questions. So length of a rectangle, 12 centimeters more than the width. If its perimeter is 96 centimeters, calculate its area. So this will be a theme throughout measurements. Sometimes we need to find unknown dimensions, length, width, whatever. And we do that using equations. So here, what we're going to do is we're going to let x equal either the width or the length. I'll just let it equal the width. And so if the length is 12 more, the length is going to be x plus 12. Now, of course, the perimeter of a rectangle is just the length around the outside. And that's the same for any shape. So for this rectangle, its perimeter is going to be x plus 12 plus x plus x plus 12. If you add up all of those, you're going to get 4x plus 24. In other words, it is the length and width added together, then doubled. So we're told that this perimeter is equal to 96. So we subtract 24. And then we divide by 4. We get x equals 18. So that means here that the width is 18. And so the length will be 18 plus 12, which is 30. And the area will just be 30 times 18, length times width. It will be 540. And because the dimensions were in centimeters, it will be in centimeters squared. 540 of these little squares will fit inside this shape here. So we always use equations when we want to find an unknown dimension. Of course, to find the area of a rectangle, we first needed to find its length and width. All right, let's now look at using some percentages in our calculations. So if we increase the side lengths of a rectangle by 20%, by what percentage will its area increase? It turns out we will get the same answer regardless of the original length and width. So let's draw a rectangle here. We'll just call its length L and its width W. So if I take the area of this rectangle, it's just area equals length times width. We know that. Now, if I increase the side lengths by 20%, remember increasing by 20% is the same as timesing by 1.2, or finding 1/20% of the original number. And similarly for W, if we increase it by 20%, we now have 1.2W. So the new area after we've increased the side lengths by 20% will be 1.2L times 1.2W. 1.2 times 1.2 is 1.44. So what we've done here is we've taken our original area and multiplied it by 1.44, which is the same as a 44% increase. The area will increase by 44%. If the area was 100, it's now 144. So this happens with all 2D shapes. If you multiply length and width by the same number k, you actually multiply the area by k squared. So let's look at going the other way. I want to increase the area of a square by 125%. By what percentage must I increase its side length? So basically, we have a square here, and we'll call its side length s. So the area of this square is s squared. If we increase the area of the square by 125%, it's now going to be 2.25 s squared. That's the new area. Increasing something by 125% means you find 225% of the original number, and that's the same as timesing by 2.25. So if the area of a square is 2.25 s squared, to find the side length, we simply square root that. So if you square root the area, you get the side length. Now the square root of 2.25 is just 1.5. Square root of s squared is s. If you want to increase the area of a square by 125%, you have to multiply the sides by 1.5, which is a 50% increase. So this works for squares. It actually works for any 2D shapes. If you multiply the side lengths by 1.5, i.e. increase them by 50%, you will increase the area by 1.5 squared. 2.25, you'll increase it by 125%. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.